Hello everyone, welcome to our weekly webinar. Today we will talk about linear regression. Our agenda for this session will be introduction to linear regression, multiple linear regression, categorical variables, validation, tips, and finally I'm gonna walk you through the practice project. Let's get started. Oops, 1 minute. Okay, let us see in what scenario we can use linear regression. Remember this map? This map shows us what model to use in each business problem or scenario. As we can see, we can use linear regression when we are trying to predict a continuous outcome. Now, what is linear regression? Let us check the data displayed in these scatter plots. First plot, number of employees and number of tickets. We can say that when the number of employees goes up, the number of tickets also goes up. What about the second plot? The mileage we put on the car and the displacement or the engine capacity. The more mileage we put, the less capacity we get from the car engine. The third graph is about advertising, spending, and sales numbers. Also, we can say when marketing spending goes up, the sales number also goes up. In general, we can say that in all three graphs, we have a relationship between the two variables, and the relationship appears to be linear, since it seems like we can draw a straight line through the data, as you can notice. Now, the idea here, if we can know the equation of this line, then we can predict the value of one of the variable depend on the other value or depend on the value of the second variable. For example, we can predict the displacement value if we know the mileage. So let's talk about this equation. To explain the equation, I used price and carat data from the diamond dataset. The equation for the linear regression is y equal mx plus b, where y is the target variable and in our case the price. X is the predictor variable and in our case carat. M is the slope of the line. B is the y-intercept or the baseline value or the value of y when x equals 0. Now, this is the form of the simple linear regression. We have a target variable and only one predictor variable. But in business, it's uncommon to build a model by using only one variable. Let us go back to our chart here. We can notice that the distribution of the price goes wider when we goes up over here. So yes, we can say that there is a linear relationship, but it's not very strong. So to make our model better, we may use more variables like cut clarity and so on. And that will lead us to our next topic, which is multiple linear regression. So what will happen to our equation if we add more variables to it? It will be like this. Y still the target variable, B0 is the intercept. or the baseline value. B1, B2, B3 is the coefficient of x1, x2, x3, and so on. Now let's move to the next topic. Categorical variables. Let's assume that we are trying to predict the expenditure using income and region. But how the linear regression equation will work with the region here? The math cannot be done. So the only way to use region is to transform this field into numeric variable. We can do that by making dummy variables. In our case, we have three categories in region. We have central, west, east. We will add two dummy variables, represent 2 out of 3 categories in the region field. And in these dummy variables, there is only 2 values, 1 and 0. Please note that the number of dummy variables should be always equal to the number of categories minus 1. As I said, in our case, we have 3 categories, and we created 2 variables. Also, please note that in Alteryx, there is no need to create dummy variables. Alteryx will do it automatically for us. Now, let's move on. How to validate a linear regression model. Okay, when we run our model, we will get some information about the model. There is 3 values we can check to know if our model is good enough or we can improve our model. The first value is p-value. The p-value is the probability that the coefficient is 0. The lower the p-value, the higher the probability that a relationship exists between the predictor and the target variable. When a predictor variable has a p-value below 0.05, the relationship between the predictor and the target variable is considered to be strong or to be statistically significant. The second value we need to check R squared. R squared is the percent of variance that explained by the model, or R squared tell us how much of the target variable explained by our model. The higher is the better. And in general, R squared more than 0.7 is considered to be a strong model. The third value is adjusted R squared. When we add more variables, R squared goes higher even if there is no relationship between the additional variables and the target variable. Adjusted R squared solved this problem, and we should use it when we have multiple linear regression. Anyway, we will discuss more about validation step later on during our practice. So let's move on. I have few tips for you from my experience with linear regression. First, always plot the numeric variables to visualize any potential relationship with the target variable. Second, be careful. Some variables that has numeric values could be categorical and should be treated as one. Finally, always check the t-values for all the variables you included in your model, especially for the categorical variables, because you cannot plot them. Those was my tips for you. So now let's go to the practice project. Let me go to the classroom. First, let me close. Okay. Okay, this practice basically redoing the diamond project that you did during the first section in this program. But in this practice, we're gonna use Alteryx instead of Excel and Google Sheets. As you know, we have one data set with 50,000 diamonds with data like cut, clarity, retail price. We will use it to build a model to predict prices for a batch of 3,000 diamonds in the second data set. Then we want to recommend a bid price for the entire batch, which will be 70% of the sum of the predicted diamond prices. I've already downloaded the data to my laptop. Anyhow, we have 4 steps here. First, understand the data, build a model, calculate the predicted price for diamond, and finally make a recommendation. Okay, let's go to Alteryx. Let me tell you a few things about Alteryx first. In these tabs, we have tools we can use to build a model or workflow. For example, in preparation group, we have tools to help us prepare data. For example, filter, formula, data cleansing. Another group, predictive. We can find the linear regression tool, for example. Now, in this area, it's the configuration area. Each tool has its own setup, and we can do the configuration here. Now, this area is the canvas area where we will build our workflow or our model. The last area here is the result area. We can check our result for each step in our model, and we can check also the final result. Also, we can always use search box, to search for any tool or anything we want to do in Alteryx. This is very useful. Now, let's go back to our practice. First, we have to import our data. So we're going to use input data tool, file, diamonds. Let's import the second data. Okay. Now, here we can get a preview about our data. We can see a few records of our data set. Remember, this is CSV file, so all the data here is text or string. So we need to modify the data type for our variables. We can use select tool to do that. For carat, I'm gonna use double. Cut, this is categorical. Cut ordinal, this is the numeric. The same variable here. Color, clarity, cut ordinal. Okay, for the ordinal, I'm gonna use N16. Price, I'm gonna use double. Also, we need to do the same thing for the second data set. So select double. We don't have price here because we need to predict the prices. Anyhow, we know few information about our data set from our classroom. For example, for carat, its numeric variable represent the weight of the diamond. The cut represent the quality of the cut. It has 5 categories. Clarity has 8 categories. Color, it's rated from D through J. We can know more information about these variables by using few tools such as, let me see here, field summary tool. This is very good tool to check your variables. So we're gonna check all the variables here. Then we're gonna add browse tool to the report and to the interactive report. Oh. Also, we can use scatter plot tool to plot the numeric variables, for example, carat for X and price for Y. Also, we need to add browse tool. So let's run our model here. Remember, this is the first step. We are trying to understand our data and to understand the relation between the numeric variables and the target variable. Also remember, we cannot plot the categorical variables and the target variable. It doesn't make sense to do that. Okay. Let's check the first report. Okay, carat. This is the distribution of values. Missing data 0, unique values 272, the minimum value, maximum value, no notes from Alteryx. Okay, let's check this variable, clarity ordinal. Also 0 missing values. Okay, we have 8 unique values. Let's see this note. This field has a small number of unique values and appears to be a categorical field. Consider changing the field data type to string. This is a true note or correct note. But remember, we have another variable, it's categorical, called clarity. It's the same, so we can use this one or we can use the other one. We can try both in our model, and we can choose the best one to include in our model. Okay, let's check the other report. This is the interactive. We can see the distribution of values in each variable here. Also here, if we have any missing values, we're gonna see part of this line in red, not in green. This is a very nice tool to check your data. Okay, let's see the scatter plot. Again, we can notice that there is a relationship or linear relationship between price and carat. So we can use carat also in our model. So after we check our data and we get a better idea about our variables, we can start building our model. Let me delete these tools in order to save some memory. Okay, to build a linear regression model, we need to use linear regression tool. Let's do the configuration here. Linear regression 1 as a name. When we select the target variable, Alteryx only give us the continuous variables to choose from. So we need to predict the price. Okay, let's choose carat and let's choose another variable here as our first model. Okay, let's add browse tool to the report and let's run the report. The model, sorry. The idea here is to try a different combination, different variables until you get the best adjusted R squared. Now we try two variables. We may try another two variables or add more variables to our current model until we get the best R squared. Okay, it's done. Let's check the report. Okay, remember what we talked about in validation section? We have to check the p-value and we have to check R squared and adjusted R squared. So the p-values looks great. All of them has stars and below 0.05. So all of the variables here are statistically significant, and it's recommended to include those two variables in our model. Notice here that Alteryx created dummy variables, created 4 dummy variables for cut. Okay, how about R squared? Also, we have good R squared. It's more than 0.7. Adjusted R squared is good also. But maybe there is a room for improvement here. So maybe we can try different combination, or maybe we can add more variables. You can try it by yourself. I've already tried different combination, and the best one I got is to include carat, cut, color, and clarity. Okay, I'm gonna run the model again. This is gonna take a minute or two. Okay, well done. Let's check the report. Again, all the variables are statistically significant. So we can use all the variables here. What about R squared and adjusted R squared? We got better values here, 0.91, which is very good. So we will consider this model as our best model. Now, we need to use this model to predict the prices in our second data set. So in order to do that, we need to use score tool. This tool has two inputs. The first one, the data, which is the second data here. And the M, it's the model we need to use, which is the linear regression model. Okay, we can give a name for the new field, or the field contains the predicted price. We give it pre-price, predicted price. Okay, let me run the model again. Always remember, when you want to use the score model, you need to check that you have the same predictors for the original dataset and for the new dataset. Because if you don't have the same predictors, or you have different data type for one of the predictors, the score tool is going to give you an error. Okay, a few seconds more. Okay, let's check our result. So this is the predicted price for each diamond in the new dataset. So now we need to sum all the diamond prices in this dataset. Then we need to calculate only 70% of this total price in order to know our bid price. So we can do the sum by using a summary tool. So predicted price, we need to sum this column. Then we will use, let me see, formula tool. Formula tool only to get 70% of the total retail price. So here we can say sum pre-price multiple 0.7. Now let's run the model for the final time. Let's sum up what we did here. First, we import the data. Then we check the data using field summary tool and scatter plot tool. We used the select tool to change the data type of the fields or the variables. Then we used linear regression tool to build our model. We tried different combination to get the best model. Then we used score tool to apply our model for the new dataset to predict the prices. Then we calculated the total prices, the total retail price. Then we multiply this total price to get 70% of it in order to get the bid price. Okay, we have an error here. Let's see. Okay, let's do it again. formula. Let's select the column, sum price 70%. Okay, let's run it again. Always remember when you are trying to use the formula tool, always check the data type of the field. It's very important to check the data type. Okay, we're done. This is our final answer. Okay, that's it for the practice project. Now we're gonna have our Q&A session. But first, let me stop the broadcasting.